Hello everyone, this is Unit 0, Fundamentals of Chemistry, Section 2, Classification of Matter. So hopefully most of this is going to be review. You probably learned it in middle school in like 8th grade, but if you didn't learn it in middle school or if that was just a really long time ago, that's totally fine. We're going to go through some of this stuff. It'll be pretty quick on most of it, but you should be able to remember most of what's going on. In order to do these notes, you should have some guided notes out for you. We provided them last class, or they're also on my website. And the guided notes have pictures, and they have practice problems at the end that you're going to complete. So while you guys are going through these notes, what I want you to do is if you don't understand something, pause and rewatch that section of the video. If after rewatching it you still don't understand, then I want you to write down an actual question. I don't want you to come to me and just say, I don't get it, I don't understand. When you come to me, you should give me a specific question that you need me to answer. Like, I don't understand this portion of the video. I think it is saying this. Is that what it is saying? Or, can you explain to me what the difference between a gas or a liquid is? When you come up to me because you don't understand something, you should have an actual question that I can answer. Because if you just come up with, I don't get it, I can't really do much with that. I don't know where to go off of that. I need to know more information about what you don't understand so that I can help you better. So at this point, there's a couple different ways that we could describe gases, solids, and liquids, or your states of matter. I could talk about their organization, spacing, motion. I could talk about volume. I could talk about kinetic energy. For this one, we're going to talk about just organization, spacing, and motion. So for a solid, all the way over here on the right, you're going to see a very, very organized pattern. So notice that not only are the particles touching, but they are also kind of organized in a hunk. They're kind of like a grid-like pattern there. One common misconception here is that people think that when things are solid, the molecules or the atoms don't move at all. But that's not actually true. The particles still move. So the keyboard that you're touching or the phone that you're touching, whatever, the particles inside that are moving right now. It's just very, 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 very small movements. Once you go to a liquid, if you heat it up and go to a liquid, adding more kinetic energy, we get a little more motion. The particles tend to slide past one another, but they're still pretty close together. They interact with each other. They still touch. Notice that it's more spread out, and now we have filled the bottom of the container here. It's going to fill the space of the container, but not all the way to the top necessarily. And there's no pattern, no arrangement for this. Then if we keep adding more energy, we're going to keep increasing our kinetic energy, meaning that the particles are going to get spread further apart. They're going to become less dense because there's more space in between them. They're going to move a whole lot quicker. It's going to be random movements wherever. They're going to bounce off the edges, and there's no sort of pattern or anything to that. We're going to be talking a lot about solids, liquids, and gases. We're going to get more specific with them, what's going on with the kinetic energy, why is the kinetic energy different. We're going to get into a lot of that this year, but I want to make sure that we understand the difference between the three of those because it seems really simple, but there's going to be a lot of instances where you're not sure if something is a liquid or solid, or you're not sure if a gas was created or something just got evaporated. We're going to talk a lot about states of matter, so we really need to make sure that we thoroughly understand what it is. All right, so now that we talked about states of matter, we're going to get into the different ways we can classify matter. So all of these classifications can exist at those three states, solid, liquid, and gas, but now there are different classifications of matter. Remember, matter is stuff, anything made out of atoms. We need atoms to have matter. And with this matter, there's really two different subsections that we're going to start off with. We're going to start off with pure substances, and we're going to talk about this side of this little, I don't know what these are called, webs? It's not a web. Whatever organizational tree whose name I can't think of right now. That's what this is. We're going to talk about the left side first, where we have pure substances, and we consider them pure because they're made of one type of thing. And then in the second half of the video, we're going to talk about the right side, which is a mixture. So keep this image in mind. We're going to come back to it at the end. So with our pure substances, remember these are substances that contain all of the same types of atoms or molecules. So it doesn't matter if it's the same atoms, it doesn't matter if it's the same molecules, but it has to be the same all the way throughout. So these guys on the side, these are considered a particle view diagram. And what this particle view diagram is it's like a zoomed in image if I was looking just at the particles inside a substance. So this is like super zoomed in. This one specifically looking at atoms, you can tell just because they are singular little circles, those are going to be our atoms. So this one here is our element because they're single atoms. And the one on the bottom is our compound. Notice that they are combined together. So some examples of this would be water in a flask. H2O is a compound, and that if I just have a flask filled with just H2O molecules, then I would consider that to be a pure substance. If I have a chunk of iron and it just has iron atoms inside of it, then that is a pure substance made out of an element. Remember, when I'm thinking of elements, I'm thinking of really anything on that periodic table. It has to be on that periodic table. Hydrogen, oxygen, carbon, nitrogen, iron, aluminum, any of those kind of things. And the last type, or the last example I have is salt, which if you remember back to, I don't know, whatever background knowledge you have, salt is NaCl. It's NaCl. And that would be a compound. Okay, so now we have molecule. So what I want you guys to do is I want you to flip back a couple of slides back to where it just had the little web design thingy, mabobbers, the tree, the web, whatever you want to call that, of the different types of matter. A molecule is not a type of matter. A molecule is a term used to describe the matter. So the definition of a molecule is that it is two or more atoms of the same or different elements bonded together. So in our particle view diagrams, the first one we have, this guy up here, you can tell that the atoms are different colors. So we've got a black one and a white one. So this is a molecule of different elements. Different elements. Whereas this guy here, they're both white dots, white circles. This is an example of a molecule of the same element. This guy down here, again, is a particle view diagram of molecules, like this guy, that has different elements in it. So I have a couple of examples here. I have a nitrogen gas, N2. We'll talk about why that's N2 and not just N a little bit later. But nitrogen gas N2, it contains two nitrogen atoms. That's going to look like this particle view diagram right here on the right. Whereas water is going to contain H2O. We need 3 atoms there, 2 hydrogens and 1 oxygen, and that would look like this guy on the right. All of these are examples of molecules. And remember, each one of these images has the same type of substance in it, so each one of these images also shows a pure substance. And in these cases, because none of the atoms are by themselves, all of these are considered to be, well, I guess not all of them are considered to be compounds. They can be considered compounds. The nitrogen one cannot, and we'll talk about why on the next slide. Here we go with our element versus compound. So remember I said that the nitrogen, the N2, cannot be considered a compound. It is a molecule because there's 2 atoms there, but it can't be considered a compound because a compound requires there to be 2 or more different atoms. So that means that N2 does not qualify. That's why on the last page, N2 could be considered a molecule. It's still a pure substance, but it's a molecule of elements. It's not a molecule that is also a compound. So elements contain only one type of atom. It has to be on the periodic table, and they have to be the same atom. So we've got iron, a block of iron. We talked about that earlier. Just pure oxygen gas would be O2. That's similar to our example of N2. It's the same elements bonded together. Or diamond. Diamond is all made out of carbon, so this is an element. On the right side with our compounds, they have to be different elements. So H2O, that's a compound. I can have a molecule of H2O. If I have one oxygen and two hydrogens, this would be considered a molecule of H2O, a molecule of a compound. Whereas if I just had O2, oxygen bonded to oxygen, that is just a molecule, not a compound. We're going to talk about salt a little bit later. We're just going to consider it a compound for now because it is two different elements. Later on in the semester, we'll learn another definition to add on to these two things. So now you might be asking, okay, cool, I got pure substances. It's one type of something. But what happens when I mix pure substances together? But I don't bond them. If I just mix them together, put them in the same location, what happens? Notice I used the term mixed. If you mix them together, you are going to form a mixture. So the key element here is that we are not going to form new chemical bonds. We are not talking about chemical bonds here. We are just putting two different things near each other. We're not forming anything new. They're just now mixed together. So for a mixture, we're on the right side of that web from the first or second slide. I believe it's the second slide. We're on the right side of that web with mixtures. So for a mixture, you need two or more different elements or compounds. It doesn't have to be all elements. It doesn't have to be all compounds. It doesn't matter. We just need two or more different things together. And they are not chemically bonded together. And because they're not chemically bonded together, we can separate them by physical means. We don't have to do any crazy chemistry to separate them back out. We'll talk about the different physical means on the next couple of slides, but let's talk about the different types of mixtures first. We have a heterogeneous mixture and a homogeneous mixture. So the prefix hetero means different. Hetero means different. So that's going to be something that actually looks different. We'll get more in depth with some examples on the other page on the next slide. But a heterogeneous mixture is something that looks visibly different. You can see the different parts of the mixture. So out of these two particle diagrams, I would say the heterogeneous mixture is this guy down here. Because on the bottom, I can see this stuff. That's one type of thing. And then I've got this guy. And then I have this guy. All together, I can see the different areas where they are. Now, if I was going to talk about states of matter with that particle diagram, I'm going to assume that the stuff at the bottom, it looks pretty organized, so I can assume that's probably going to be a solid. The other ones, these guys up here, I can't really figure out if it's a gas or a liquid. So I'm never going to ask you, are those in the particle diagram a gas or a liquid? Because it's hard to tell. It's hard to tell how zoomed in I am in the image. But you should be able to identify solids pretty easily because they'll be organized down at the bottom. Now, a homogeneous mixture, or homogeneous, homo or homo means same. So this is going to be a mixture that looks the same throughout. You wouldn't be able to pick out the different things visibly. It'd be really hard to tell where the different stuff is inside it. So here's our heterogeneous mixture. So again, that's a mixture of a substance that are noticeably different from one another. You can actually see the different parts of the different things in it. So a good example here would be, I apparently was hungry when I wrote this, different foods. Fruit salad. In a fruit salad, if you're looking at a fruit salad, you can see the chunks of pineapple mixed in with the chunks of strawberries, mixed in with the grapes or whatever. You can see all of the different parts. You can easily pick out the different parts. Italian dressing, oil and vinegar. You can see the different parts of the Italian dressing in there. They're separated a little bit, not completely, they're still mixed together, but it's easy to see how they could be separated because you can see the different parts. Sand and water, they're going to be mixed together, but the sand's going to kind of settle at the bottom, right? You can visibly see the different parts of a heterogeneous mixture. In this example on the right, you can see the different iron filings, the dark atoms, mixed in with the salt, and you could actually pull out that iron just with a little magnet. So that would be a physical means. You can pull it out using something. A homogeneous mixture is something that you can't see the different parts of. So milk. Milk is made up of a bunch of different stuff, water being one of them, and calcium and all that jazz up in there. fat, everything up in there. You can't see the different parts of the milk, but they are a mixture. You can separate them physically. If you've ever like put milk in a freezer, it starts to separate. You can see it a little bit. Just because you can't see the different parts doesn't mean you can't separate them. It's a little more difficult than with a heterogeneous mixture, but you can still do it. So an example would be salt water or sugar water. If I have salt water, I can get the salt out by just evaporating off all the water. I didn't chemically combine anything, I just evaporated the water. It turned from a liquid into a gas and it went away. Same thing with sugar water. You can evaporate it off the water and separate the sugar and the water again. Okay, milk, Kool-Aid, or any sort of solution. That would be a solid that got dissolved into a liquid. You can not see the different particles in there, but you can separate them without doing any sort of crazy chemistry. So I talked about mixtures, and I talked about how they can be separated using physical techniques. We're going to be doing a lab with this. We're going to be doing a lab where I give you a mixture, and you guys have to figure out how to separate all the different parts and collect all the different parts. So what we did here is we gave you a data table of all of the different techniques you can use, what they do, and some examples and the instruments. So I want you to kind of pay attention to this because you're going to do a lab with this real soon. So we've got filtration over here. Ooh, get rid of that. So I have two different filtration techniques here. I've got filtration that separates a solid from a liquid. An example would be chalk and water. I can grind up chalk and I can mix it with water. Eventually the chalk's going to kind of settle down at the bottom, right? So I've got a solid mixed in with a liquid. So I'm going to show you a picture of what this filtration technique looks like on the next slide. But I'll need a beaker, a funnel, and some filter paper. Filter paper kind of feels like cardstock, but think of like a coffee filter. When you drink coffee, which I'm sure a lot of you do, you might not make your own, but when you make coffee, you put the coffee grounds into the coffee filter and water gets poured through it. The coffee filter holds onto the solid and the water is able to go through. That's the same thing that we're doing with this filtration technique. With another filtration technique, you could pick out solids of different sizes. A lot of people like to go panning for gold. I don't know that anybody ever finds any, but people, go up in the mountains, whatever, and go pan for gold. And they get like that mesh that separates the rocks from the gold particles. That is technically a type of filtration. We don't really do that in this class because I'm not going to give you a whole bunch of different size solids and say like, go for it. So that's just not really a chemistry thing, but it's definitely a technique you can use. Another way you could do that would be like if I gave you paper clips and gravel or something, you could pick out the paper clips with your hands or with tweezers, and technically that would be filtration or manual separation. For magnetism, you need a magnet, and you need whatever you're trying to separate to be magnetic. So the big key thing here is iron. If we ever say anything about iron, one of the answers is going to be magnets. You need a magnet to separate that out. We also have evaporation. And evaporation is when we want to separate a solid that is dissolved in a liquid. So when I say solid dissolved in a liquid, I mean we started with a solid and we dissolved it into a liquid, so it's no longer solid. We call that an aqueous solution. This would be like salt dissolved in water, which is very different from what we had going on up top, where we just had a solid sitting in some water. Like sand sitting in water is very different from salt dissolved in water. So if I have salt dissolved in water, we call that an aqueous solution, aqua, dissolved in water. And what you're going to have to do is you're going to have to get rid of the liquid. So the way you do that is through evaporation. You're going to heat it up. You're going to boil off the liquid there. So you need some sort of heat source. You need a Bunsen burner or a hot plate, and you need there to be a beaker for that. The last one is distillation. And distillation we really can't do in our lab. Distillation is kind of dangerous. I mean, they do it in, like, we think of distilleries, like alcohol distilleries. But really what you're doing is you are separating two liquids or three liquids. You're separating multiple liquids, and the way they're being separated is they all have different boiling points. You heat them up and they turn into a gas at different times. So when they turn into a gas at different times, each time you hit the boiling point, it turns into a gas. You can get rid of one thing and collect it somewhere else. So one big thing about distillation is that you can go from a liquid to a gas and condense that thing back to a liquid somewhere else. So this would be like if I wanted to separate water and rubbing alcohol from each other. I would have to boil it. They boil at different temperatures. Rubbing alcohol boils first. And then the rubbing alcohol would leave the container, turn into a gas, and get moved somewhere else, and you could condense them back into a liquid, and the two things would be separated. This is how they make alcohol. Like if you think back to Prohibition and you think back to making moonshine and why making moonshine was so dangerous, it's because when you have moonshine, you have different types of alcohol. Ethanol, methanol, all sorts of different alcohols in there. And you're not supposed to drink, well, you guys are not supposed to drink any alcohol, but you are not supposed to drink methanol. It's toxic, it is dangerous, it is poisonous. But when you make moonshine, part of it is that it makes methanol. So when you make moonshine, you're supposed to distill it and you're supposed to get rid of the methanol. But if you don't do that properly, as most people did not, you leave all that poisonous, toxic alcohol in there, and then that's why people got really, really sick back in Prohibition. So on the right, we're going to start with the distillation. So let's say I have my two liquids down there. So I've got my two liquids down there. We'll go rubbing alcohol and water. And the rubbing alcohol is going to have a lower boiling point, so it's going to start to boil first. So the rubbing alcohol is going to turn into a gas, and it's going to go up. Now when it goes up, it's going to go down here. It's got to go through this other tube. Now do you see where it says water out and water in? The water is going to cool down that area of the tube, and that gas is going to turn back into a liquid. So now our rubbing alcohol is over here, and our water stayed over here. So we've got two separate liquids now. For the middle one, this is a technique that you're for sure going to be using a lot this year. This is called gravity filtration or just filtration. So what you do, you have your little beaker, and you're going to pour your solid and your liquid through the filter paper. So there's a piece of filter paper sitting in that funnel. Don't just pour it through the funnel, otherwise it's all going to go down to the bottom. And what's going to happen is the solid is going to stay on the filter paper and the liquid is going to go down into the beaker. On the left-hand side, we have our evaporating dish. This is for evaporation. This would be like if you had salt water. You could do this way with an evaporating dish sitting on wire gauze and a Bunsen burner underneath, or you can do this on a hot plate with a beaker with your stuff in it. It just takes a lot longer. All right, so we're back to our little flow chart here. Oh, I found the words. It's a flow chart. So I'm back at my little flow chart web thing, and when we look at matter, remember if it is one type of substance, we have a pure substance. And with a pure substance, we have things that are found in the periodic table being elements. That's a single type of atom. Or we have two different elements bonded together, which is a compound. Now, something that we'll talk about in another unit is how we can go from a compound to an element using a chemical process. Because compounds are chemically bonded, we have to separate them in a special chemistry way. We can't do that with what we're doing in this unit. On the other side, to go with a mixture, for a mixture, we have our homogeneous mixtures, which look very, very similar all the way throughout. And then we have our heterogeneous mixtures, which look different throughout. Remember, mixtures are two or more different types of substances just mixed together. So we can separate those through our physical processes of filtration, evaporation, distillation, or magnetism. Did I miss any? I don't think so. Okay, so now at this point, you guys should be able to go through the practice problems on your notes. You should be able to answer all the practice problems. Pay special attention to those particle diagrams because you're going to see a lot of those on your tests and on your quizzes. So if you don't understand the particle diagrams, make sure you come sign up for the access time and I can help you with that. But you should be finished with your practice problems on the last part of your guided notes at this point.